My name is Suyash Nagar, and I am here to present my capstone project pitch for managing machine learning projects from Duke University. Before we begin, let us quickly understand review criteria. First, I will start with opportunity evaluation and showcasing the use case I have identified for this demo. Then, we will define and document use case with crisp DM business understanding process. After that, we will go through validation plan and ML system design document. Finally, we will discuss on some of the potential risk which can lead into production issues. I smartphone is a concept focused on providing the agriculture industry with cutting edge smart infrastructure by leveraging IoT, cloud, and edge computing for automation or augmentation tasks. Precision agriculture uses information technology to ensure that crop and soil receive exactly what they need for optimum health and productivity. It also ensures profitability and sustainability and protection of the environment. In 21st century, agriculture industry is dealing with multiple challenges. It has to produce more food and fiber for growing population. Additionally, labor workforce is shrinking due to urban migration. It has huge impact on developing or agriculture dependent countries. To overcome these challenges, there is a need to adopt to more efficient and sustainable production method. Some of the challenges faced by agriculture industries are labor force shortage, climatic changes, low returns specifically for small farmers, lack of planning and management, increase in production cost affect market sustainability. So there has to be a sustainable way to keep the cost down. To overcome all these challenges and in order to meet global supply and keep up with emerging demand, there must be a radical shift in farming practices. With this, we will now evaluate the opportunity. One of the usage of herbicide is to remove unnecessary plants or weed. The usage is significant because it can control weed in almost any stage of the growth. However, there are many side effects on human as it can cause nausea or diarrhea like symptoms on consumption. Also, it can be very harmful for people working in field. Exposure to herbicide can cause eye, skin, nose or throat irritation. Nevertheless, it also lead to environmental issues. High usage can lead to decreased photosynthesis, cell division, and amino acid production in plant. Polluted water from field can also impact aquatic ecosystem. So now, let us answer the three questions. Is there a problem? Yes. Labor shortage in agriculture has created a bottleneck for increase in production and reduce produce related quality issues such as use of herbicide or removing weed. Can ML or AI help us solve it? Yes. With right training data, it is possible to train drones and robotic component loaded with ML AI model to solve the problem. Does someone care about it? Well, Agriculture feeds the world, impact economic development, and can help in creating more sustainable system. So, yes, farmer, agriculture manager, and entire industry cares. CRISP DM process stands for Cross Industry Standard Process for Data Mining. CRISP DM provide a structured approach and is a robust and proven method. Model is a sequence of event and one of its key feature is backtracking to previous task and repeat certain action. No wonder it serves as the base for all data science process. Business understanding. We will start with problem. The target user for our model or solution is agriculture industry and mainly farmers. The problem we are trying to solve here is excessive use of herbicide for weed removal due to excessive use of chemicals. How is it solved today? In traditional farming method, the entire field is sprayed with chemicals such as herbicides. What are the gaps in current state? Due to labor shortage, instead of spot treatment, entire farms are sprayed with pesticide and herbicide, which has environmental consequences. Let us define success. Business impact. Minimize crop wastage, controlled use of herbicide, and increased revenue. Target. Outcome. Reduction in herbicide usage, less dependency on human labor. Output. For computer vision model, output metrics will be precision, F1 score, and recall. Some of the constraints we might face. Data containing weather, expected weed type, and how much herbicide to spray should definitely be put into the usage. Constraints. Data containing weather, expected weed type, and how much herbicide to spray. Some of the key factors are libraries of images to spot the difference between plant and weed. This step will be very crucial as we will be needing very realistic images. Seasonality and crop to weed correlation will be vital to know what to expect. Findings, solution validation plan. As we know, this step is an iterative approach. So we will move on from one iteration to another. In iteration 1, we will try to identify weed versus plant with the creation of mockup. Iteration 2, historical data with mockup created during iteration 1. In iteration 3, we will use some of the real data with heuristic model to identify and predict. With heuristic model to identify and predict weed versus plant. In iteration 4, we will try using computer vision or custom vision to identify weed from plant. Then we will compare the result from iteration 3. In iteration 5, we will continue improving on CRISP DM process, refine model with relevant feature until optimal solution is reached. For training data, we will go with the 80-20 or 70-30 ratio. We might use computer or custom vision ML model for image processing. With this, we will move to ML system design. Here, We'll try to answer three questions. Number one, cloud versus edge. In this particular scenario, edge ML will be optimal solution due to remote location of farm or internet availability. Next, offline versus online. We will leverage online learning depending upon internet availability. Model can be trained based on performance and factor like season to predict wheat versus plant. Now, we will review some of potential risk which can leak in production. First, we will look into data drift. Training serving skew may occur if data is collected is only subset and does not identify all target feed. Next, concept drift. Drastic climatic change can cause possible concept drift. For instance, if there is an unexpected rains causing to grow wheat which is not expected during this harvest time. In order to resolve this, there might be a adjustment or retraining required. Well, this brings end to this session. Thank you for watching and providing your feedback. Thank you.